So in this presentation we're going to look at regulator second stages and how they work, everything you need to know about regulator second stages to be fully prepared for the PADI Divemaster and Instructor exams. What we're actually going to look at is the way a second stage works, downstream valves, pilot valves, common second stage problems. What are the different types of second stage? Second stages do not differ in design as much as first stages, I would argue. Most differences are purely cosmetic. Pilot valve second stages are probably the biggest difference. That is the exception to the rule I've just stated. A pilot valve second stage is pretty different to most of the standard second stages you might come across. The difference between a balanced and unbalanced second stage is not nearly as significant as it is with first stages, in my opinion, but balanced and unbalanced second stages do exist. How does a second stage work? Point for your notes, a scuba second stage is designed to provide air to a diver on demand, pretty much when they inhale. We already know, if you've watched my video on first stages, that the first stage delivers air to the second stage at an intermediate pressure above ambient. The job of the second stage is kind of in two parts. It reduces this intermediate pressure above ambient to ambient pressure because the human body needs to be breathing air at a pressure equal to the pressure surrounding it. The other aspect of a second stage, or the other job it does, is to deliver air to the diver on demand. Here are two pictures of second stages, a second stage in the closed position and a second stage in the open position. I now want to focus in on some of the aspects of this second stage, some of the mechanics on it, to help you answer the questions that you may be asked in the PADI exam. Looking at this second stage, we have the various parts of it labelled. What I want you to focus in on is this part here. This is the valve orifice, and the valve itself, the part that actually moves to open and close the valve. What I want you to pay attention to is the direction in which this valve opens to provide air to a diver when they need it. With this valve in the open position, with the air flowing to the diver, we realize that the air is flowing from the first stage in the direction I've just drawn this arrow, and when the valve opens, it opens in the same direction the air is flowing in. It is what we refer to as a downstream valve. It opens in the same direction that the air is flowing into it from the tank. Now what we need to focus in on is this part of it, this spring here. This spring is what closes the valve when the diver is not inhaling. So we have the pressure of the spring working upstream, working against the flow of air. And we have one other aspect of pressure working in that direction. We actually have the ambient pressure working to help close this valve. Looking at this again, what we have working to close this valve is a spring. And that spring, the tension of that spring, is a pretty important factor in a second stage. The spring is working to close it, but it is being assisted by ambient pressure. Ambient pressure is also working to assist in closing the valve. What we have to do when we're servicing a reg and tuning a reg is make sure that the tension that the spring is exerting to close the valve, the spring pressure, is just fractionally larger than the force of the air or the pressure that the air is exerting against the valve. We need that spring to close the valve when the pressure, the ambient pressure, plus the spring pressure is just a tiny bit more than the pressure working in the other direction, but just a tiny bit. So what is the pressure working in the other direction? Well, the pressure working in the other direction is the pressure coming from the first stage, which, from watching my video on first stages, you hopefully now know and you remember that the first stage delivers air to the second stage at an intermediate pressure above ambient. So what do we have working against the valve, trying to push the valve open? We have intermediate pressure, and in addition we have ambient pressure. So ambient pressure is working to open the valve, and it's working to close the valve. They cancel each other out. When we're tuning a second stage, and a properly tuned, properly serviced second stage, what will happen is that the spring needs to be capable of closing the valve against intermediate pressure above ambient. So the spring needs to be tuned to be just ever so slightly stronger than intermediate pressure. So what we should really be adding in here to the annotation on this diagram is that the bias spring is set to intermediate pressure plus a tiny bit. Now we need to look at what makes the second stage a demand valve. And we have the demand lever there, and we have the diaphragm there. These are the two things that make it a demand valve. Looking at it in the open position now, what we have to imagine is that a diver inhales, and that is going to suck the diaphragm inwards. That diaphragm is going to push against the demand lever, and looking at the way the demand lever is set up, when that demand lever moves up, it's going to be pulling against the valve. It is attached to the valve, and the valve is going to be pulled into the open position. So inhalation pulls on the diaphragm, which pushes the demand lever, which pulls the valve open. As long as the bias spring is set to a tiny bit over intermediate pressure, a very small amount of inhalation effort is going to be required to pull that valve open against the spring. If the spring is set to be significantly stronger than intermediate pressure, then significantly more inhalation effort would be required, which is why when you have a regulator that is difficult to breathe from, it probably needs retuning, it needs to be reserviced, so that the second stage can be better tuned to the first stage, reducing the inhalation effort required. Let's focus in on what we mean by a fail-safe design. We can see that the spring pressure plus ambient pressure is trying to close the valve, and intermediate pressure plus ambient pressure are trying to open it. Spring pressure is set to intermediate pressure, or a tiny little bit above, so it is a finely balanced thing. If that spring was to fail, which is possible, it's a fairly delicate part of the regulator, now we've only got ambient pressure trying to push the valve closed, yet we have intermediate pressure plus ambient pressure trying to push it open. The resulting thing would be that that valve would come open and we would get a continuous flow of air, which is what we want for it to fail in a safe.
Where downward not equal of the downstream static zone, the bias
Key things we need to know about regulator second stages, points perhaps for your notes. The downstream design of the valve, which we've now looked at, is what makes the regulator fail-safe. You may well see the word fail-safe in a PADI exam. What does fail-safe mean? It means it fails in a safe way. When our regulator is the thing that we need to provide us air underwater, if it was to fail, we want to make sure that it fails and gives us a constant flow of air rather than no air at all. That basically means that it has been designed so that if the spring was to fail, the spring that closes the valve, remember, if that spring was to fail somehow, then the valve would fall open, the air would flow through the regulator to us, we would be losing the air fairly quickly, we'd need to make a prompt ascent to the surface, but we would be able to make a safe, reasonably slow ascent to the surface, breathing off this regulator as it free flows, which is of course why one of the skills we have to teach in the open water diver course is how to breathe off a free flowing regulator should our fail-safe regulator fail. It is a demand valve because it only provides air to us when we demand it, when we inhale. And because the air we exhale vent out into the water surrounding us, that is why we would refer to it as an open circuit regulator. What does the second stage do? It reduces the pressure supplied to it by the first stage, which is a pressure which is equal to ambient pressure plus an intermediate pressure. It takes that and it reduces it to ambient pressure. A question on second stages that mentions pilot valves, so I'm briefly going to explain what a pilot valve is and how it works. Here we have a picture of a pilot valve both in the closed position and in the open position. So I'm now going to zoom in on these pictures to explain in more detail exactly what is happening and how the pilot valve works. Looking at a pilot valve second stage, what is missing here compared to the normal second stage we saw is a spring. There is no spring trying to push the valve closed. So we can see the air pressure that is coming from the first stage trying to push that valve open. What is it that's keeping it closed? Well, air pressure is also able to pass down through the center of the valve and into the pilot chamber. That pilot chamber has the air that is now pushing against the other side of the valve. So the air is pushing the valve open, and at the same time it is coming through the center of the valve and pushing the valve closed. Which is going to win? Well, that's going to be based on the surface area the air is working against. The air that is working against the valve trying to push it closed is actually pushing against a greater surface area than the air that is trying to push the valve open. So because the air pushing the valve closed is working against a greater surface area than the air trying to push the valve open, the air that is trying to push the valve closed wins the battle, and the valve remains closed as long as that pilot chamber is sealed and no air is allowed to escape from it. So of course what happens is that when we want air to flow, when a diver inhales, we need the pilot chamber to have air escaping. So now you can see that that tilt valve allows air to escape from the pilot chamber, meaning the pressure in the pilot chamber will be less than the pressure of the air that's trying to push the valve open, and as a result the valve will indeed open. Basically, you are very cleverly using the pressure of the air coming from the first stage to not only open the valve, but also to close the valve. What is going to make that pilot valve, tilt valve assembly move so that air can escape from the pilot chamber? Well, as you can see in the diagram, the pilot valve, tilt valve assembly connects to the diaphragm. And when a diver inhales, what will happen is that the diaphragm will move inwards and it will pull on this tilt valve assembly, making the air escape from the pilot chamber. So I'm trying to draw here the diaphragm and something that is connecting to the diaphragm and connecting to the tilt valve assembly, so that when a diver inhales, it will indeed move that pilot valve, tilt valve assembly. And that is basically how a pilot valve works. What you really need to know is that when you see the word pilot valve, you know that we are talking about something that is utilized in a second stage, and it uses the pressure from the first stage to close the valve as well as open it. The key things to know about pilot valve second stages are that rather than using a spring, a pilot valve second stages utilizes the pressure coming from the first stage to open and close the valve. This reduces the inhalation effort required when using a pilot valve second stage as opposed to a second stage that is using a spring. The downside is that they tend to free flow a lot more easily. An awful lot more easily, in my opinion. I have tried using them on a few occasions, and quite frankly, I find them rather frustrating. And another obvious thing is that they are a lot more complicated to service. Basically, you can always identify the diver on a dive boat using a pilot valve, because they will probably be messing around with it, trying to get it to work properly, or they'll be the one who's always jumping into the water and their regulator is free-flowing. Finally, I'm going to look at some of the most common second stage problems. This is just something that every dive instructor or dive master needs to know. It's probably not tested very much in the PADI exams, in fact, but when the seat of a second stage regulator, the downstream valve, wears, the regulator will start to free flow. It will usually start with a couple of bubbles, just a small trickle of bubbles coming out of the second stage, and that's when you know that the seat of your second stage needs replacing, or in all likelihood that will be the cause of it. Now, the other thing that you will often see people complaining about when it comes to second stage is when someone comes up to you and says that the second stage is breathing wet. They're getting small or moderate or even large amounts of water coming into their second stage with every breath. So what is the cause of that? The most common and obvious cause to look for is just look at the mouthpiece. Is there a split somewhere in the mouthpiece, usually where the mouthpiece is actually wrapping around the hard plastic body of the second stage? That is always the first thing I look for when someone complains that a regulator is breathing wet, that the second stage is breathing wet. A split mouthpiece. Very quick, very easy, and very cheap to fix. If it's not that, The next thing I do is I look at the exhaust valve. Now, it may be possible to see that from the outside of the reg, just looking in where the bubbles come out of the reg when you exhale, in through what is usually referred to as the exhaust T. And when you look in there, you should see a round or oval rubber disc that is closed in normally, but when someone exhales, very easily flaps open to let the exhale breath escape. These things sometimes become folded over against the plastic body of the exhaust tee, and then obviously whether they're exhaling or not, that little rubber disc is in the open position, allowing water to flow back into the second stage after the diver has finished exhaling. Or it could be a little bit of debris or something that is actually forcing the disc, that rubber disc, to remain open. So always have a look inside the exhaust tee and see if you can see any sign that that might be the cause of the wet breathing regulator. You may of course have to unscrew the front of the second stage, pull the diaphragm out to get a better view of that exhaust valve. It's often not very difficult to do, and a very sensible thing to do if someone is complaining of a wet breathing regulator and you have already identified that it's not the mouthpiece causing it. Because if it's not the exhaust valve causing the regulator to breathe wet, and it's not the mouthpiece causing the regulator to breathe wet, then it is going to be the diaphragm. So you will definitely need to unscrew the front of the regulator to have a look at the diaphragm and look for any splits in that diaphragm. Both the diaphragm and the exhaust valve are made of an incredibly thin bit of rubber, think balloon, and it's almost that thin a piece of rubber that is making up these components. So it is quite possible for them to have a split in them. Cockroaches love to eat them, and that might be what is allowing water into the second stage and causing it to breathe wet. So there's just a bit of really useful information for a dive pro to help a diver who is complaining about a wet breathing regulator. I hope you enjoyed that video, and you are now very, very keen to come dive in Roatan and learn to become a dive instructor with me. Please go to my website, goprocaribbean.com, if you want to find out more about the IDC that I offer every month, and if you are sharing links to these videos to help other people who are studying their dive theory for the Divemaster exam, please link to my website, www.goprocaribbean.com, rather than linking to the YouTube channel, because at the website they will actually find all the videos organized into the different theory sections, and then they will also find the videos listed in the order that it makes most sense to watch them in. Thank you for watching. Don't forget to like this video and subscribe to my YouTube channel. Maybe even like my Facebook page, GoPro Caribbean.